Hi everyone, this is Soumyadeep Paul, a mentor at CodeCardus and a software developer at Amazon. And I welcome all of you to day 10 of our system design series. Now, in the previous video, we learned what is throughput, we learned what is bandwidth. Now, in today's video, we will learn and we'll see how we can actually estimate throughput and bandwidth in an interview-based question. Okay, so we will be doing an example, a numerical today. So just to revise, just as a reminder, what was throughput? What was throughput? Throughput was nothing but it is basically either the amount of work completed per unit time, per second. So that can be in terms of a web service, in terms of a system, in terms of a computer system. It can be either number of requests per second or number of transactions per second, or number of, say, messages per second. Okay. Then what was bandwidth? Bandwidth is the amount of data transferred per unit time. So what was bandwidth? Bandwidth was amount of data transferred per unit time. In the previous video, I explained you that if the throughput is X requests per second and every request on average requires Y data, then the total bandwidth becomes X into Y. So the unit of X into Y can be something Mbps, megabits per second, Gbps, gigabits per second, okay, or Mbps, megabytes per second, or Gbps, gigabytes per second, anything, any amount of data per second. Okay. Now let us do a numerical. Okay. Let us do a numerical. So what is the numerical? The numerical is, suppose you are going to give the interview of Amazon and you are giving the interview of Amazon and your interviewer told you to design a messaging app. Okay, design a messaging app. Okay, and the very first step he asked you to design in a messaging app was to do estimations for throughput, bandwidth, and data storage. Okay, so you need to do estimations. Estimations for what? Estimations for throughput, estimations for bandwidth, and estimations for data storage. Okay, so let us see how we'll do this, how we'll calculate these. Okay, and this is a problem. This is what students often miss. A lot of you, when preparing for system design interviews, especially in HLD interviews, you design the whole system. You say services, you name the services, you name the components, you put load balancers, you put Redis, messaging queues, etc. But you miss out on estimations. You don't practice these estimations. So if the interviewer asks you to make estimations for throughput, bandwidth, and data storage, you then mess up. So we will practice this. Okay, and these are very simple, very simple. Okay, so when someone asks you to do estimations, first of all, always start with throughput. Okay, always go in this order: first throughput, then from throughput you will be calculating bandwidth, and then you will be calculating data storage. Okay, so first throughput estimations. Okay, now for throughput, in a messaging app, you may need to figure out the total number of active users. So you may make a guess, say 5 million, 10 million, 50 million, 100 million. Or you may ask your interviewer that, hey, what would you like to be the active number of users in this messaging app? So let's say the interviewer says that active users, daily active users, okay, also called as DAU, daily active users is, say, 50 million. Okay, let's say it is 50 million. So if daily active users is 50 million, that means, and if your interviewer says you that, okay, these are the total number of users, not the daily active users, but daily users, or monthly users, but not active users, then from normal users, you have to take a percentage, say 40%, 30%, or 60%. So and so percentage of your users are active users. So you have to come up to the active users number. Because in totality, there may be a lot of users. Okay. In totality, the database may be storing data for 200, 300, 400 million users. But there just may be 50 million active users. So you always have to estimate for active users, not total users. Okay. So daily active users, let's say 50 million. Now, since you have daily active users as 50 million, let's say the next piece of estimation would be, let's say that, okay, how many messages every person on average would be sending every single day. So let's say number of messages on average a user sends every day. Okay. How much? Let's say 40. I guess 40 is a good number. How many do I send? How many messages do I send? Do I send 40 messages? Yeah, I guess I can say that on WhatsApp, on an average day, yes, I do send about 40 messages. Some days it may be a much more, some days it will be less, but yeah, on average I can say I send 40 messages. Again, this is an assumption. So if you're making an assumption, you need to tell your interviewer properly that yes, this is an assumption I'm making. You need to ask your interviewer that whether he or she is comfortable with this assumption. If they find this assumption completely wrong, then they'll correct you. Otherwise, you are free to go ahead with this assumption. Okay, great. So now, if there are total active users is 50 million and number of messages on average an active user sends every day is 40, then therefore total number of daily messages would be what? Would be 50 million into 40. So this becomes to be how much? 2000 million, which is 2 billion messages per day. Okay, 2 billion messages per day. Huge amount of messages. And actually, we won't just be taking 2 billion. We will be taking 3 billion messages per day, 50% more. We'll increase this by 50%. Usually, this is what I do, 50% increment. Why will I be doing this 50% increment? Because now if I'm saying that 2 billion messages throughout the day, it won't be a uniform stream of data, is it? It won't be a uniform source of messages, uniform stream of messages. That 2 billion messages will be uniformly divided throughout the day. Obviously not. Maybe the peak number of messages is somewhat at evening, 7 p.m., 8 p.m. But say from night 2 a.m. to morning 8 a.m. Those 6 hours. At that time, there are barely any messages because people are sleeping. So it won't be a uniform distribution. There will be 6 to 8 hours where the traffic is very less. And then there will be 6 to 8 hours, maybe during the morning, the office hours, or maybe towards the evening. During those periods of time, the traffic will be much more. So that is why we take a 50% increment. So that even when the traffic is much more, it will not be a bottleneck for our systems. Okay. So this is a good practice to always do that, so that you are already prepared for some worst case scenarios. So you have taken 50% increment. Great. Now you have 3 billion messages per day, massive. So what will be the throughput at the end? So your throughput finally comes out to be 3 billion messages per day, which means around, how many will it be? let's say around, it will come around 35,000. 35,000 messages per second. Okay. You can also do this. So 3 billion, 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 86,400. So yes, 34,700. So yes, it is coming around 35,000 messages per second. Okay. So this is your throughput. This. Now we can also double it. We will actually say that actually in reality this is 70,000 messages per second. Why? Why are we doubling it? Because for every message, for every incoming message, there will be an outgoing message, isn't it? There will be an outgoing message. There will be an outgoing message. Because the server receives the incoming message, and then the server also has to send the outgoing message, send back that message to the end recipient, isn't it? It receives the message from the sender, it sends it to the recipient. So for every message from sender to recipient, the server handles two requests. First is it is receiving the message, second is it is sending the message. So in a way you can say not messages, 70,000 requests per second. Okay. So 35,000 messages per second, which turns out to be 70,000 requests per second. So that is about throughput. Now let us do some bandwidth calculation, bandwidth estimation. Okay. Let's do some bandwidth estimation. Now in bandwidth, what is bandwidth? What did we learn? That bandwidth is nothing but the number of requests multiplied by the average data size of every request. That's it. So let's say an average message is about how much? Say around 100 bytes. And see, if you're thinking that how do I know that a message is of 100 bytes? That is something you'll gain with practice. The more you practice, the better these assumptions will be. That you're assuming every person sends 40 messages per day. You're assuming the average size of a message is about 100 bytes. The more you practice, the better these assumptions will be for you. Okay. So if this is the case, then bandwidth will becomes what? Bandwidth becomes 70,000 into 100 bytes. 70,000 requests per second into 100 bytes. This turns out to be how much? This turns out to be, let's say, 70,000 and 2 more zeros bytes per second. This turns out to be, this is 7 million bytes per second, so it turns out to be 7,000 kilobytes per second. This turns out to be 7 megabytes per second. Okay. This. So this is your bandwidth, 7 megabytes per second. Okay. Pretty simple, isn't it? You find out your throughput, and once you have found out your throughput, you just need to multiply it with the data size. That's it. That becomes your bandwidth. Now let's talk about some database estimation. Database, also called as data storage estimation. Okay. So we saw that you're getting 35,000 messages per day. 35,000 messages in one day, isn't it? And one message consists of 100 bytes. This is something we saw in our throughput estimation. This is an assumption we made while calculating bandwidth. So, total storage to store messages for 1 day. Total storage to store messages for 1 day is equal to 35,000 into how much? Sorry, 35,000 messages was not in 1 day. Sorry, it was in 1 second. My bad. It was in 1 second. So in a day it will be what? In a day it will be 86,400 into 100 bytes. This will be total storage required to store messages for 1 day. These many messages per second, these many messages per day, these many bytes per day. So this turns out to be how much? Let's calculate 35,000 into 86,400 into 100. This is the total number of bytes. If I divide it by 1000, then it becomes the total number of kilobytes. Again, if I divide it by 1000, then it becomes the total number of megabytes. Again, if I divide it by 1000, then it becomes the total number of gigabytes. So this becomes 302.4 gigabytes, which for easier calculation we can say 300 gigabytes. Okay. Simple? Pretty simple. Okay. Now this is for 1 day. So therefore, total storage to store messages for 1 year will be what? 300 into 365, which is 365 into 300, these many gigabytes. And again, if I divide by 1000, it becomes how much? 109.5 terabytes. Okay. So we can say this is around 110 terabytes. Okay. And you don't just stop for 1 year. You then say total storage to store messages for 5 years. That will be around 550 terabytes. So this is the data you need to start with. Because whenever you're building a system, you need to have the data that at least you need to have the storage that at least supports your system for the next 5 years. So you have to think ahead. You cannot just start a system with the storage requirements for 1 month or 6 months or 1 week or 1 year. You need to have for at least 5 years. So in an interview also, at least always calculate for 5 years and show for 5 years. That is a very good sign, a very good programming practice. Okay. So that's it. Now, this was the data required only to store the messages. If your interviewer asks you to find the data required to store the user data, the user metadata, the messages metadata, chat metadata, etc., then for other things you have to again estimate using the same process. Okay. But I hope this was clear. Now I hope you have got some idea about how to do throughput estimation, bandwidth estimation, and data storage estimation. Okay. So that's it for today's video. And if you want to learn these concepts in a much more in-depth manner and have much more practice from developers who themselves are working in Mang companies like me, then do join Code Cardos. And I'll see you all in the next video.